Here we are again, model 4.3, flow patterns in agitated vessel. Enjoy the class. So introduction, flow pattern in agitators, explanations, radial versus axial flow, of course, baffle and draft 2. Excuse me. So we'll try to look at the introduction. So everything about the agitator we're using will depend on the characteristics of the fluid. Of course, size and proportionality of the tank, baffles, and agitator. We mentioned that the type of fluid or the type of material determines the kind of agitator we want to use. This means that flow pattern is related with the geometries of the tank, of course, stirrer and baffle, liquid properties, and the stirrer speed. And there are three principal currents in the vessel during agitation. We have the radial, the tangential, and of course, the longitudinal. Now look at it. We'll try to bring out agitated vessel, what happens. We have the radial, the longitudinal, and then the swelling. And that's what we have shown. Number 1, number 2, and of course number 3. And we have what we call a vortex. You can notice this vortex easily if you have a bucket of water and the water is dirty. You want it to settle. It contains a lot of suspended particles, and you want the water to settle. You can dip your hand into the bucket of water and turn it with speed, round. At some point, you now leave it. As the water is moving around, you see that the middle of the water will be like it is depressed, whereas by the sides would be like they are coming up. So this is something we have to take into consideration while designing our agitation vectors, so that we will not use the occurrence of vortex to reduce the quantity of our fluid. If the fluid needs to splash, then it will affect our agitation or mixing quality. Now explanations, radial, longitudinal, and swelling. Now tangential component induces vortex, like we said, and swelling, which in turn, creates a lot of problems. Now in such cases, fluid particles are followed by another fluid particle, So now when you look at radial, longitudinal, and swelling, we see that these are different types. Swelling is defined as stratification at various levels with no longitudinal flow. This can be minimized by placing the shaft slightly away from the center. So you see, we can shift the shaft instead of being at the center of the agitation vessel. It can be shifted a little, and this will reduce the stratification as a result of swelling. We're now trying to compare the radial versus axial flow patterns. So you can see how that is taking place very close to the impeller. Baffle and draft tube. These are the things we use, when we talk about flow patterns, and we'll have some problems. The higher the speed, the deeper the vortex. That vortex will say that as you turn down your bucket of water with high speed, then that center will keep going down, and this will also result to problem in proper mixing. And there are some solutions we can use. One is install baffles. We mentioned these baffles. You can visualize the baffles as if you put your two hands at the opposite edge of the bucket. Now those two hands will now make the water not to swell completely round. It will now disturb the smooth swelling, and then also increases the mixing and reduce the vortex. 2, off central installed agitator. Like we said, you can shift the shaft and agitator instead of mounting at the middle of the vessel. We can shift it a little bit. And of course, flow patterns depends on Reynolds number. Look at, we have listed it there. Reynolds number between 1 and 10 near the turbine We have laminar flow, other zones almost static. That's when it is very small, flow is small. Reynolds number above 10, we have laminar axis slow. Flow starts from blade tips. Reynolds number between 100 and less than 1000. That's between 100 and 1000. We have a transition. And then Reynolds number above 1000 gives us turbulent flow in the whole of the tank. Of course, we have given the equation for Reynolds number, d squared n rho divided by mu. So mu is the viscosity, this is the density. So we can calculate the Reynolds number when we have all this. And that helps us to, model flows in pipes, whether it's laminar, transition zone, or turbulent flow. Introduction to flow patterns. We looked at flow pattern in agitators, looked at some explanations, radial versus axial flow patterns, baffle and drafting. I believe you enjoyed the class. Thank you very much and see you in the next class.